Hi everybody, welcome to the Manifold channel. We're going to take a look at our continuing series of comparisons between Manifold System Release 9 and Esri's ArcMap plus Spatial Analyst by focusing on a feature that's brand new in Spatial Analyst. It was just added just this last year in 2019. It's something Esri is justifiably proud about, and what it is, it's a Euclidean distances with barriers, so-called Euclidean allocation distance and back direction. And with barriers, what's this all about? Well, suppose you have a raster here that has some sort of flat or other terrain. Let's say this is the water, and then you've got some barriers, say land, which is here and representing barriers. And what you want to do is you want to see the path from this red dot to here, and you want to see it in terms of Euclidean straight lines, which have got to be routed around the land. And they've got to be straight lines minimizing the cost that is the distance. That's not an easy thing to calculate, especially for something like this where it's kind of got to go around the edges. Euclidean lines are straight lines. That's what Euclidean means in this sort of context. So finding that is a very different deal than finding the path or just finding the Euclidean straight line from this dot directly to there that goes straight through to the land. When Esri introduced this, they started blogging about this. This is from a Esri blog entry in July 2019. It's a great illustration, and I think it conveys it very well. It's very impressive that Arc has done that. And so what we're going to do is we're going to use ArcMap together with Spatial Analyst to do those calculations to see how long they take and what the workflow is like and compare them to Manifold. I'll give it away. Manifold does all these computations in 7 to 8 seconds, which Esri takes typically about a minute, 50-some seconds to a little over a minute, something like that. So it's considerably faster. What we're going to work with is this raster here, which is a terrain elevation raster of a central part of Florida around the Lake Wales Ridge region, 5,300 pixels by 5,300 pixels. And to create some barriers, we've used Sentinel with this value expression here, value less than 40, to create the barriers that you see right there. So we're going to work with this barrier version to work around with barriers. The Manifold version is here, and here you can see exactly the same raster. And what we've done is we've knocked out those pixels to create equivalent barriers in Manifold, so we can do an apples-to-apples comparison. When Manifold saw what Esri created, Manifold was so impressed that Manifold decided, hey, we can do that too. So they created equivalent versions of it. Now, this comparison is pretty aggressive because ArcMap, as we see it here, ArcMap Standard Edition is $2,750 plus $2,500 per seat for all these cool tools for Spatial Analyst to get all these great tools that you see here in the Spatial Analyst geoprocessing tools. And Manifold, in contrast, is typically under $500. This particular license was required $475. Usually, you can buy Manifold for $425, $495, something like that. It's virtually always on sale, so that's a pretty good deal. Let's get right to it. And the first thing we're going to compute is the equivalent of Euclidean allocation. We're going to do the closest Euclidean source. That's what Manifold calls it. We're going to use barriers and compute through here. We're going to simplify the output raster name to not make it so long. Click OK. Now I'm going to click Add Component, and Manifold's off to the races. It's going to take it about 7.5 seconds to make this computation. It's at 5 seconds, 6 seconds, 7 seconds, and it's done. When you're used to seeing everything happen in 1 or 2 seconds, to take 7 or 8 seconds is a very long time. I'm just not used to it, but be that as it may, it's a lot quicker than sitting around for a minute watching Arc do it. And I want to color this exactly the way Arc colors it. So I'm going to use this drawing here that was this raster image there, which already uses a color ramp that was hand-created to look like Esri's. And I'm going to copy the JSON description of that color ramp. This is kind of a quick trick to, if you really want to save duplicating a lot of effort. Style, pixel, add a style pixel property, and we're going to paste the JSON for that style into that string, and click OK. And there, it colors it the way Esri would color it. Let's do the next one real quick, which is going to be a closest Euclidean distance, and that's that transform right there. This is equivalent, by the way, to the Esri processing toolbox. It's just that I've restricted it to showing only those processing tools, geoprocessing tools that that have closest to CleoLS in their names. So instead of hundreds here in the list, we just have these to pick from. That makes it easy to pick. Again, I'm going to use a simpler name for the output raster. This is equivalent to Euclidean distance for Esri. And click Add Component. And again, oops, I did it on the wrong raster. So what it does whatever is the raster image right here. Now, one nice thing about Manifold is that that's not a tragedy, because we can just come here and the one we just created. Let's just nuke it. We're not going to use that. Click back here on the contents, and let's rerun that. Let's do the closest Euclidean distance. When everything happens in just a couple seconds, it's no heartache if you got to redo it, because it's very quick to redo. It's not like you've been sitting looking at it for minutes and minutes, waiting for the thing to complete, and then you realize, oh gee whiz, I did something wrong, so I got to redo it. All right, let's rerun that again. And again, that's only going to take it 7 or 8 maybe seconds, maybe 8.5 seconds, and it's very quick. And it's going to create this thing right here, the distance image. Let's drag and drop that into the map. And where's our distance image here? Euclidean distance image. Let's let's copy the Esri formatting that we have in here. Copy that. Click cancel. Then here, distance image. Let's create properties. Style pixel. Amazing how you have to spell the stuff right when you're working with these products. Click that, click OK, and there. That's Esri style formatting that shows the Euclidean distance routing around, these barriers that have been knocked out. Okay, and now let's do, last but not least, let's do the closest Euclidean direction, which is not one of my favorites. I think it's kind of a goofy thing, but Esri does it, and so Manifold does it too. And let's compare. Closest Euclidean direction. Click OK. This too will take 7 or 8 seconds, because it's got to compute, what the path, Euclidean path direction is from each raster, where it starts out from each raster going to the destination grain point, and that's going to be, let's see the direction right there. So let's drag and drop that into the map, and that's a very typical display. Let's format that. This is the last time we're going to be doing this trick right here, so just bear with me. Copy. I really should have done at least one of these. Manifold style, where you can see how fast it is when you're not trying to deliberately duplicate what Esri for color ramps use, but you can just use the built-in manifold ones, because then it's just a point and click, so it's a lot faster using the style dialog than doing this kind of manual stuff. But that's okay. It's nice to have this manual stuff for when you want it. And there you have that display. These lines here are kind of an artifact of rendering. They kind of go away as you kind of zoom in. I don't know why it does that, but no doubt that's something that's going to get dealt with in the next release. They don't appear when you print them. All right, let's go to Esri, and let's see how fast Esri does all this stuff too. We're going to start with Euclidean allocation. Right here, there's Euclidean allocation. Now, I got to be very careful how to do this, because Esri is a little bit tricky. So we want to do all this. The input barrier or feature class is going to be this guy here, the Euclidean barrier that we computed. And everything else I think we can use just by default. So let's click OK, and let's see what happens. Mercifully, we're not going to sit around waiting here for like 2 or 3 minutes. It's distributing operation across 4 parallel instances. We're running here with a parallel processing environment of 100 factor of 100%. That means ArcMap and the parallelized geoprocessing modules are making their own decision how many operations they want to launch. So it decided in this particular case to run 4 parallel instances. Manifold ran across all 48 threads available, running on a 24-core Threadripper here. So Arc could have used up to 48 threads, but it only chose to use 4. So that's kind of weird. But hey, I'm sure it has reasons for doing what it's doing. And let's see how long that takes. It's getting close. Like I say, it takes it about a minute to do this. Sometimes a few seconds less, sometimes a few seconds more. But in that ballpark of about 1 minute. There, it succeeded. And you can see that took 57 seconds, and that's comparable to right there, which is what Manifold computed. Manifold using slightly different formatting. I guess it was the formatting was based on a different Esri run. That's okay. You kind of get the idea what it did. Let's keep on going here. Let's do the let's see the closest Euclidean distance, and to that we use the Euclidean distance geoprocessing tool. The feature data source is going to be the Florida drawing. The input barrier raster is going to be this raster we computed with set null. Everything else again is going to be as is. And let's see what it shows for a how many parallel threads to do this time. It used 4 parallel instances. Okay, that's pretty cool, but it's nowhere near the 48 that Manifold used. I feel like we should run Manifold at least one time. Just repeat one of those runs to show you how what it looks like to see all 48 threads light up, because that's kind of cool when you see that in Task Manager. In fact, let's use Task Manager right there. Let's see what Esri's doing. You can't really tell because there's what other stuff is going on, but you can tell. You'd see this big pulse if where Esri was running all that stuff. It was running it really all in parallel. All right, let's close the Euclidean allocation there. We're still waiting for Euclidean distance. And this too is going to take us about 55 seconds, a minute, something like that. Again, way more than the 8 seconds it took Manifold. So what did that take? That took 55 seconds. Okay, here's an example, unfortunately, of when Esri gets it wrong. One of the really charming things about ArcMap, one of the things I really like about ArcMap, is how it automatically will format things for you. See, it does automatically all these format breaks. It tries to do its best. And that generally works extremely well, except when it doesn't. And here's one case where the raster that it created is just all kind of goofy. It's for some reason it chose to allocate zeros to all the intervals, so the raster comes out all that same color. If we went to the effort of reformatting that, restyling it with Arc, you'd see that in fact Esri did calculate it correctly. It's just formatting it wrong. So no harm done. That's all right. I'm willing for it to go wrong a couple times when it does that, if in exchange for all the times when it goes right. Starting to sound like an Esri guy, I know. Okay, now let's do Euclidean back direction, and that's equivalent to the direction. Click on that again. Input raster feature source is Florida drawing, and the input barrier raster is going to be this one that we calculated. Let's click OK. And again, for third and last time, we're off to the races. Third and last time, this is also going to take about a minute. And let's talk about why ArcMap is taking a minute to do what Manifold does in 7 or 8 seconds. The primary reason, there's actually 3 reasons. The first is that ArcMap itself is not parallel. It's a single-threaded application that can run one thread in background, so really you can call it dual threads. Here's that background thread running, Euclidean back direction. Whenever it's launching one of these tools are parallelized. They may only run 4 or 9 threads, but at least they're parallelized. I know it seems like they're paralyzed sometimes, but they're parallelized. That's really slow. It's like having, because this is a single-threaded application. It's a bottleneck. It's like having an 8-lane highway with a 1-lane on-ramp and off-ramp. Traffic jams build up in those on-ramps and off-ramps. So you get to use that 8-lane highway for a mile or two, and then you're in a traffic jam to get on and off, and that really slows down the works. That's the first delay. The second delay is that these packages aren't particularly well parallelized. It's first-generation parallelization. Okay, that's done. Took 1 minute and 5 seconds. And here, too, it created this grayscale raster, which was what the default was when Manifold created that grayscale raster. Usually, Esri colors it like this. I don't know why I colored that one with a grayscale, but in this case, it did. I promised you that we would take a look at I have to work with some of the stuff off screen here. I'm going to delete this from the map. I'm going to delete this from the map. And let's delete this from the map as well. And let's rerun this let's do close Euclidean distance. That's a nice one. We use barriers. And it's going to automatically iterate the name of this when I fire it up, so that to give it the next name up. And I'm going to do this so you can see what it looks like to have 48 threads running. And here we go. In the Task Manager, you can see, boom, it launched all 48 threads here. It did all this in just like 7 or 8 seconds. But you can see that peak on each and every one of those threads. All of them were used. Manifold computed the graph to dispatch parallel processing to all those 48 threads, and off it went. And if we actually take a look at how long all these things took, you can see what took Esri minutes. Here it just took 6 seconds, 7 seconds, 7 seconds, 8 seconds. So that's considerably faster than the results that we saw Esri doing, which were taking like 1 minute and 5 seconds, and what was here? 55 seconds. All right. And here, 57 seconds. And the third factor why Manifold is so much faster than Esri with all this parallel stuff is that Esri's data storage is parallel unfriendly. They're using GDB here, and that's not particularly well optimized for parallelization. When Manifold is using not only a fully parallel application that is doing fully parallel functions that are parallelized for, like, fifth generation parallelization to dispatch 48 threads without stepping on each other, but also the native map format that Manifold is using is the Radian database parallel database engine map format, which is very, very fast and very, very powerful parallel. It's actually faster than Postgres or even Oracle, and it's been tuned, deliberately designed for parallelization. So when you combine all those factors, the humble $475 package Manifold can do in 7 or 8 seconds what takes Esri typically a minute, even for these very complex and sophisticated applications that were just recently added by Esri, using absolutely the state of the art of what an indisputably high quality company Esri can do. In fact, that's really leads to a very good combination. If you're an Esri person, you're doing a lot of work in ArcMap or ArcGIS Pro, it's kind of an optimal approach is to continue using Esri for all the things that you like about Esri. But when it comes time to do a more complicated calculation that's going to take you minutes or hours or days in Esri, or which God forbid maybe ArcMap or ArcGIS will fail at doing it all or crash, dispatch that to Manifold, run it in a couple seconds in Manifold, and then bring it back to Esri. Manifold is so fast that the round trip, sending the data from Esri out to Manifold, doing the computation in Manifold, and then bringing it back to Esri, can be minutes or hours faster than doing it all in Esri itself. I hope you've enjoyed this series of demonstrations. The intent is not to slam Esri, it's to look at how different parallelization works and how things have evolved over the years and what the different options are. Thanks for watching, and goodbye from Manifold Land. Well, that was fun. If you want to see more, visit us at www.manifold.net. As always, Manifold delivers the world's most advanced, highest quality spatial products for GIS and DBMS at a low price that you can afford. Once again, that's manifold.net. See you soon.